Today we are going to discuss how 3D printers can be used to print parts of robots. While they can't print the entire robot with all its internal components and electronics, they can create many of the structural components. Here's how 3D printing is used in robotics.
Hello and welcome to GunSet, a channel for intelligent and curious people like you. Before we proceed, let me tell you one thing. If you have not subscribed yet, please subscribe. It means a lot to me. And if you have already subscribed,
prototyping. 3D printers allow for rapid prototyping of robot parts, making it easier to test and iterate on designs. Custom parts. They can create highly customized parts that might be difficult or expensive to produce using traditional manufacturing methods. Complex shapes. 3D printers can produce complex shapes and geometries that would be challenging to create using other methods. The 3D printing process for robot parts. 1. Design and modeling. CAD software. Engineers use computer-aided design, CAD, software to create a digital 3D model of the desired robot part. Detailed specifications. The model must include precise dimensions, tolerances, and material specifications. 2. Slicing. Software. Slicing software breaks down the 3D model into a series of 2D cross-sections, or layers. G-code generation. This software also generates G-code, a set of instructions that the 3D printer can understand. 3. Material selection. Plastic filaments. Common materials include ABS, PLA, nylon, and TPU. Material properties. The choice of material depends on factors like strength, flexibility, heat resistance, and chemical resistance. 4. Printing. Extrusion. The 3D printer heats the filament to a molten state and extrudes it layer by layer onto a build plate. Support structures. For complex geometries, support structures may be necessary to prevent sagging or warping. 5. Cooling and finishing. Cooling. Once the layer is printed, it cools and solidifies. Support removal. If support structures were used, they are carefully removed. Post-processing. This may involve sanding, painting, or other finishing techniques to improve the part's appearance or functionality. 6. Assembly. Integration. The 3D printed part is assembled with other components, such as motors, sensors, and electronics, to create the complete robot. Key benefits of 3D printing for robotics. Rapid prototyping. Quickly iterate on designs and test new concepts. Customization. Create unique parts tailored to specific needs. Complex geometries. Produce intricate shapes that would be difficult with traditional manufacturing. Reduced costs. In some cases, 3D printing can be more cost-effective than traditional manufacturing methods. Limitations of 3D printing for robot parts. While 3D printing offers numerous advantages for robotics, there are certain limitations that make it unsuitable for all applications. 1. Material strength. Limited strength. Some 3D printed materials, especially those commonly used for prototyping, may not have the same strength and durability as materials used in traditional manufacturing processes like machining or casting. Structural integrity. For applications requiring high load-bearing capacity or resistance to extreme conditions, 3D printed parts might not be sufficient. 2. Production scale. Limited efficiency. For large-scale production of robot parts, traditional manufacturing methods like injection molding or stamping can often be more efficient and cost-effective. Build time. 3D printing can be relatively slow, especially for large or complex parts, which can increase production costs. 3. Dimensional accuracy. Tolerances. While 3D printers have improved in terms of accuracy, they may still struggle to achieve the tight tolerances required for some robot components, such as gears or precision bearings. Warping. The cooling process can sometimes lead to warping or distortion of the printed parts, affecting their dimensional accuracy. 4. Surface finish. Roughness. The surface finish of 3D printed parts can be rougher than that of parts produced by traditional methods, which may affect their performance or appearance. Post-processing, additional finishing steps like sanding or polishing may be required to achieve the desired surface quality. 5. Material limitations. Limited material selection. While the range of materials available for 3D printing has expanded, there are still limitations compared to traditional manufacturing. Some materials, such as high-strength alloys or specialized composites, may not be suitable for 3D printing. 6. Intellectual property. Design piracy. 3D printing can make it easier to replicate designs, which can raise concerns about intellectual property protection. Advantages of traditional manufacturing methods. Traditional manufacturing methods, such as machining, casting, forging, and stamping, have been used for centuries and continue to be relevant in many industries. Here are some of their key advantages. 1. High strength and durability. Materials. Traditional methods often use materials like metals and alloys that are known for their strength, durability, and resistance to wear and tear. Structural integrity. These materials can be processed to achieve the desired properties, making them suitable for applications requiring high load-bearing capacity or resistance to harsh environments. 2. Precision and accuracy. Tight tolerances. Traditional manufacturing techniques can achieve very tight tolerances, ensuring that parts meet precise specifications. Dimensional accuracy. This is crucial for applications where even slight variations can affect the performance or functionality of the product. 3. Large-scale production. Efficiency. Traditional methods are often more efficient for large-scale production, as they can be automated and optimized for high volume. Cost-effectiveness. The economies of scale can reduce production costs per unit, making these methods competitive for mass production. 4. Proven reliability. Mature processes. Traditional manufacturing techniques have been used for many years, and their reliability and consistency are well established. Risk mitigation. The mature nature of these processes reduces the risk of unexpected failures or quality issues. 5. Wide range of materials. Material versatility. Traditional methods can work with a wide range of materials, including metals, plastics, and composites. Tailored properties. Materials can be selected and processed to achieve specific properties, such as hardness, ductility, or corrosion resistance. 6. Intellectual property protection. Design security. Traditional manufacturing methods can make it more difficult to reverse engineer products, protecting intellectual property. Reduced piracy. This can be particularly important for products with unique designs or proprietary technologies. That's it for today. Keep watching Wooden Slate. See you in the next video. Till then, goodbye, take care and stay safe.